3,000 meters beneath the ocean, humans can't survive. No sunlight, crushing pressure, complete darkness. Yet something is down there working. Welcome back to the channel. I'm Hillary. Let's dive in and go beneath the sea.
Now we go beneath Subsea 3500, because this is where the calculations from the DP system become physical force. The computer may be the brain, but the propulsion and thruster systems are the muscle. When wind, waves, or currents push the vessel away from its required position, the DP system calculates how the propulsion system needs to respond. The thrusters then generate controlled thrust against the surrounding water. That force can help move the vessel forward, backward, sideways, or rotate it to maintain the required heading. But it isn't simply about having powerful thrusters, it's about controlling them precisely. Too little thrust may not be enough to counter the forces acting on the vessel. Too much thrust could create an unnecessary correction. The goal is balance. The DP system continuously calculates the forces required and coordinates the available propulsion to produce the desired response. And all of that requires one critical resource: power. 3,000 meters beneath the surface, the ROV has arrived. But reaching the seabed is only the beginning. Now the machine has to see, navigate, and work. Its powerful lights cut through the darkness as cameras reveal a world hidden from the surface. Pipelines stretch across the seabed. Subsea trees, manifolds, cables, and complex structures emerge from the darkness. Every movement of the ROV is controlled from the vessel above. Inside the control room, operators watch multiple screens. They monitor depth, position, heading, cameras, sonar, and vehicle systems. Their hands move across control joysticks. A small command is transmitted through the umbilical. Seconds later, the ROV responds thousands of meters below. The umbilical is more than a cable. It is the lifeline connecting the machine to its operators, carrying power, communication, and control signals between the surface and the deep. The ROV uses multiple thrusters to move forward, backward, sideways, and vertically. This allows it to carefully position itself around subsea equipment. But the deep ocean is not an empty workspace. Currents can push the vehicle. Visibility can change, structures can be extremely close, and precision is essential. The operator must understand the ROV's position while relying on cameras, sonar, sensors, and other information. The machine is no longer simply exploring the seabed. It is becoming an underwater work platform, and this is where the real capability of the robot begins. Because the ROV doesn't just have eyes, it has hands. In the next scene, we will see how robotic manipulators and specialized subsea tooling allow humans to perform delicate engineering tasks thousands of meters beneath the ocean. Where human hands cannot reach, robotic hands take over. At 3,000 meters below the surface, seeing subsea equipment is only half the challenge. The real question is, how do you touch it? The answer is the ROV's robotic manipulator arms. Controlled by an operator on the surface, these powerful arms allow the machine to perform precise tasks in an environment where human hands cannot survive. The ROV approaches a subsea component. Its cameras give the operator a close-up view. Slowly, the manipulator extends toward a valve, connector, or specialized tool. One careful movement at a time, the operator guides the robotic arm into position. ROVs can support inspection and valve operations, tooling, surveying, and other subsea activities. But at extreme depth, precision is everything. Cold temperatures, enormous pressure, currents, and limited visibility can make even simple movements difficult. The ROV must remain stable while the manipulator performs the task. Thrusters control the vehicle, hydraulic systems power the arms, cameras and sensors provide information, and the operator coordinates everything from thousands of meters above. What looks like a simple robotic arm is actually the final link in a sophisticated engineering system. A human moves a control on the surface. A machine moves its hand on the seabed. Where humans cannot reach, robotic hands take over. And in the darkness, the work continues. 3,000 meters beneath the surface, the ROV moves slowly through the darkness. Its lights reveal pipelines disappearing into the distance and subsea structures resting silently on the seabed. The machine is small compared with the enormous ocean surrounding it. Yet, it represents something extraordinary. Human beings have created technology capable of extending their reach into an environment they cannot physically enter. Above the ROV, an offshore vessel continues its operation. Inside the control room, operators remain connected to the machine through cameras, sensors, communications, and the umbilical. Thousands of meters separate the people from the equipment they are controlling, but the connection remains precise. A command from the surface becomes movement on the seabed. The ROV continues forward, its lights cutting through the darkness. Then the camera pulls back. The machine becomes smaller, the seabed becomes enormous, and the scale of the ocean becomes clear. 3,000 meters down, humans may not be able to work, but their machines can.
If you enjoyed the journey into the deep, don't forget to like, subscribe, and join us for the next one. Until then, stay curious.